China's growing hypersonic force is now assessed as capable of reaching American carrier groups in the first minutes of a Pacific conflict. After a decade of stalled projects and canceled contracts, and with the Pentagon's 2027 Taiwan forecast drawing nearer, the Air Force needed a hypersonic strike option it could actually deploy. Instead of another high-cost design, it turned to a Colorado startup and 3D-printed rocket parts. The result, unveiled in September 2025, has an unlikely name: Angry Tortoise. And for the first time in years, the United States believes it may have a way to close the hypersonic gap. Over the last 2 decades, hypersonic weapons have moved into the center of how major powers think about future conflict. Not only do they travel at Mach 5, or 5 times the speed of sound, but they also have the potential to be highly destructive. Some may even be armed with nuclear warheads. Thus far, true hypersonics haven't been used in combat yet. However, Russian President Vladimir Putin recently claimed that the country's Kinzhal missile, which Russia has deployed in the war against Ukraine, as well as the Zircon missile, a sea-launched cruise weapon with an air-breathing engine, are both hypersonic systems. In November 2025 alone, Russia launched 27 Kinzhal strikes against Ukrainian thermal power plants, hydroelectric nodes, and fortified bunkers. But experts dismiss the hypersonic label as exaggeration. The Kinzhal, they argue, is little more than an air-launched ballistic missile with a flashy name to draw headlines. But it's China that should concern Washington. According to a late 2024 report from the Department of Defense, Beijing now operates the world's leading hypersonic missile arsenal. Secretary of War Pete Hegseth agrees. In the event China launches an amphibious assault on Taiwan, which experts expect could happen by 2027, the nation's suite of hypersonic missiles, quote, can take out our 10 aircraft carriers in the first 20 minutes of a conflict. At the core of that arsenal sits the DF-17, a medium-range system built around a glide vehicle instead of a traditional re-entry body. It can reach roughly 1,500 miles and climb to speeds near Mach 10 before entering the upper atmosphere. From there, it does something U.S. defenses were never designed to counter. Instead of following a fixed arc like a ballistic missile, the glide vehicle holds a flatter trajectory and can shift left or right as it descends. That movement forces American radars to track a target that refuses to behave predictably, collapsing the reaction time for carriers and their escorts. According to Hegseth, quote, China is building an army specifically designed to destroy the U.S. And so far, many critics believe America has struggled to answer. In recent years, the United States has suffered significant setbacks in hypersonic missile technology. Early in 2025, the Navy revealed that it halted work entirely on its Hypersonic Air-Launched Offensive Anti-Surface Warfare, or HALO program, an air-breathing hypersonic cruise missile effort. The service blamed budgetary constraints and said it would, quote, revalidate the requirements, with an emphasis on affordability. For their part, the Air Force had been trying a different path. Officials contracted Lockheed Martin to build the Air-Launched Rapid Response Weapon, a boost glide system meant to prove the service could carry a hypersonic weapon under a bomber and release it cleanly. The missile flew several times, but more than half of the early tests ended in failure, and the project was set aside until the Air Force could reassess its direction. Lockheed Martin also worked on another design that aimed to give the service a fast, maneuverable anti-ship option. Still, budget negotiations tore the program down before it reached flight testing. The Army took yet another route with Blackbeard, a program still active today. Created to shorten development timelines and lower costs, Blackbeard isn't a single missile, but a series of efforts meant to build lighter, more affordable vehicles that can survive launch, reach hypersonic speed, and carry a useful payload without relying on exotic propulsion. The goal is to field something practical rather than pursue a perfect design that arrives too late to matter. With programs that overlapped, competed for the same resources, or stalled in early testing, industrial delays have made the country look far behind its rivals. Now, America may finally have a counterpunch on the horizon, with a fitting, ironic name. In September 2025, at the Air and Space Forces Association's Air, Space, and Cyber Conference, the U.S. Air Force announced its latest tactical flight demonstration, the Angry Tortoise, a clever combination of an aerial target designed to simulate ballistic threats and a liquid-fuel rocket engine into a new, lower-cost hypersonic missile. The name is a playful jab at the Air Force's failure to keep up in the international hypersonics race. The The Angry Tortoise project is being developed by Ursa Major, a Colorado-based aerospace company that specializes in liquid rocket engines with support from the Air Force Research Laboratory. At a panel, the company's CEO, Dan Jablonski, spoke about the dangerous gap. Quote, "The only way we're going to be able to maintain our advantage is to innovate, and we have to innovate faster than our adversaries." And this is exactly what they did. The key element of the current Angry Tortoise design is Ursa Major's 4,000-pound thrust-class Draper rocket motor, which allows the missile to change trajectory mid-flight. The same unpredictable maneuvering that makes China's DF-17 so difficult to counter. Despite being liquid-fueled, it can be stored at room temperature for extended periods. Unlike the volatile, corrosive propellants most liquid rockets require, that gives it the tactical flexibility of a solid-fuel motor with the performance advantages liquid systems offer, all at a fraction of the usual cost to build. Like its predecessor, the Hadley engine, Draper is made mostly of 3D printed parts, reportedly about 60%, which helps keep production costs down and manufacturing timelines short. Angry Tortoise pairs Draper with the front section of an existing rocket called the Economical Target 2, built by Teledyne Brown. The ET-2 is normally used as a surrogate ballistic missile in test ranges, which means its outer body already has the shape and stability needed for high-speed flight. It also provides internal framing and volume that can hold the guidance package and the new propellant tanks. By starting with hardware that had already been proven in repeated test shots, AFRL avoided designing a new airframe from scratch. With this different approach to hypersonic development, one built around reusable airframes, printed engines, and production lines that can scale without the delays that crippled earlier efforts, for the first time, AFRL is trying to prove that hypersonics do not need to be exotic or prohibitively expensive to field. A working Tortoise would show that the United States can build these systems quickly and in quantity, the only way to keep pace with China's expanding arsenal. Now, the only question is whether it actually works. Angry Tortoise's December test launch is scheduled to take place at the Army's White Sands Missile Range in New Mexico, the same range where the United States carried out the Trinity test on July 16, 1945, the world's first atomic detonation. For now, the missile's full capabilities will remain entirely under wraps, at least during its initial flight. The December test will only push Angry Tortoise to about Mach 2, roughly 1,535 miles per hour, due to physical limitations at the launch site. Though White Sands is a sprawling range complex, hypersonic systems can fly so far, so fast, that they often outrun even the largest facilities on land. However, Ursa Major has announced plans to test Angry Tortoise at long range over the Pacific sometime in 2026, where it can be pushed closer to its actual limits. No U.S. liquid engine has flown at hypersonic speed since the X-15 program ended in 1968, which means Draper will be entering conditions the country has not attempted in more than 50 years. So far, however, the Draper rocket motor has already been hot-fired more than 300 times in ground testing. Though AFRL officially labels this a technology demonstrator, which gives them room to walk away if things go wrong, the intent is clear. The team's immediate goal is to prove that a missile built from mostly printed parts can be made quickly, tested often, and scaled without the usual bottlenecks. It's expected that later versions may change shape, swap engines, or shift to different launch platforms, depending on the mission. If the test flights succeed, and the Angry Tortoise moves up to the development stage, it could become the weapon the U.S. needs to close the gap in the hypersonic arms race. Or it could join the growing list of promising programs that never made it past the demonstration phase. For now, all Washington can do is wait and hope the Tortoise, slowly but surely, finally crosses the finish line.